Good morning, X Games fanatics. I'm so happy to see you all tuning in for the most intense event of the games, the Knuckle Huck. Today, we are watching Marcus Kleveland take on the Huck with a humble confidence and a killer soft smile. We're going to take a first look at this wild trick before we analyze his style and technique. Wow, did you see that, folks? As we see here, Kleveland makes 3.5 rotations in the run with a 1260-degree turn. The velocity that he gained with the lead up to the knuckle allows him to have a greater resistance to a change in motion through the trick in the air. Because of this, he needed a good amount of torque to counter the resistance and enable him to make the rotations and land the correct way with stability, which we will discuss in a bit. We'll take the trick step by step as he takes on the knuckle. Kleveland's center of gravity is roughly around his waist, and he's able to hold stability before the trick as his center of gravity is over his snowboard, which is his support base. As he takes off on the trick, there is no longer a support base that is connecting him to the ground, so here he uses his angular momentum to do his turns and perform the trick. Kleveland uses torque in his trick as he applies force to the ground and pushes off with his snowboard and front foot to begin his rotations. As he hits the knuckle, he uses more torque to continue his rotations, as we see here. Since he has a pretty great rotational inertia, his torque has to be greater to change his rotational state. After he pushes off the ground briefly on the knuckle, he tucks his snowboard towards himself so that he has a smaller moment of inertia. We can see how this enables him to rotate more easily around the axis of rotation, since the rotational inertia is lower at this point. He makes another full rotation and a half after the knuckle, and is able to do so since he can easily start and stop his rotations at this point. As he flies into the air and puts his life in the hands of gravity, angular momentum is conserved. We see through his first couple of rotations off the ground before he made contact with the ground again how this is conserved. However, he then uses more torque as he pushes off the ground, which creates more angular momentum. Right after he leaves the ground again, his angular momentum is yet again conserved until he lands on the ground. Since there's no external applied force as he is making rotations in the air, the momentum stays constant. It changes as he makes contact with the ground again and is no longer constant. When he pushes off the knuckle, his center of gravity is again under his support base of one side of the snowboard, allowing him to be able to use the torque to create more rotation and rotational speed with stability. As he lands at the end of the trick, he brings his snowboard and feet back under his center of gravity so that he can land smoothly and flash that softy smile under his mask. And that's the physics of snowboarding for you, folks. Thanks for tuning in, and we hope to see you at the next Marcus Kleveland fan club meeting.